So here we go with the next set of questions. Number 11, the number of electrons in the dot diagram of carbon. Dot diagrams include valence electrons only. So if you look at the configuration of carbon, it'd be 1s2, 2s2, 2p2. Valence is highest energy level, which are the 2's here, the second energy level. So the number of electrons in the second energy level is 4. So we would expect to find 4 electrons in the valence configuration. Tellurium, in number 12, we're looking for pairs of electrons. Tellurium, it has 6 valence electrons. You would know that by writing the configuration, or by now you may be picking up on the fact that you can count the tall columns on a periodic table. The hydrogen column, the alkali metals, all have 1 electron in their outer shell. The column that starts with beryllium at the top has 2 valence electrons. All of the transition metals, the D sublevel block, are supposed to have 2 valence electrons. Sometimes they don't follow the rules, but they're supposed to. Then the boron family has 3, the carbon family has 4, the nitrogen family has 5, the oxygen family has 6. Tellurium is in the oxygen family, so you would expect to find 6 valence electrons. That's not 6 valences, messed up there. 6 valence electrons. So for our 6 valence electrons, there'll always be S2P4. That makes 6. Oxygen is a 2S2, 2P4. The element underneath that, sulfur, is a 3S2, 3P4, and so on. So tellurium's in that family. 6 valence electrons. When you put electrons in a dot diagram, you put the 2 and the s electrons. Now we have, or in the s sublevel, the 2 s electrons go in the s sublevel. Then according to Hund's rule, you would go single, single, single pair for the remaining 4. So if you do that, you end up with, in the p sublevel, 2 electrons, then a single and a single. So the number of electrons in a dot diagram would be 6. There are a pair of them in the S sublevel, 1 pair in the P sublevel, and the other 2 in the P sublevel are singles. So the correct answer would be 2. Isoelectronic in number 13 means having the same electron arrangement. Beryllium has 4 electrons. If it loses 2 electrons to make a positive 2 ion, now it has 2 electrons. The other element that has 2 electrons as a neutral atom is helium. Number 14, the element that's most likely to obey the filling order, you would be looking for an element that is not in the D sublevel or the P sublevel. I'm sorry, I said that wrong. You'd be looking for an element that is not in the D or the F sublevel. The S and the P sublevels follow the rules all the time. So all of these elements are in the D or F except for phosphorus. So the answer should be A. Number 15, the orbital and the valence or outer shell of arsenic. Arsenic has 5 valence electrons. It's in the 5th column. So it'll be an S2P3. What are the 2 orbitals? S and P. So the answer is C. How many sublevels in the 5th energy level? The number of sublevels in an energy level is equal to the number of L values. Oops. So if for n equals 5, L could equal 0, 1, 2, 3, or 4. Because L goes from 0 to n minus 1. Each one of these L values is the value is a sublevel. So we'd be looking at S, P, D, F, G. How many is that? 5. So the answer is E. Orbitals in a p sublevel, I think by now we probably know that one. That would be B. There are 3 orbitals in a p sublevel. The s sublevel has 1 orbital. The d sublevel has 5 orbitals. Number 18, how many electrons have a positive 1/2 value? Krypton it has 36 total electrons. Its configuration ends in S2p6 because it is a noble gas. That means that every available orbital is full of electrons. Half of those, and when you have 2 electrons in the same orbital, one spins clockwise, positive 1/2, the other spins counterclockwise, negative 1/2 for s values. So since there are 36 electrons and half of them have to be spinning clockwise, the answer would be 18, C. 19, how many values of the quantum number m are in the f sublevel? For an f sublevel, L equals 3. M can go from negative L to positive L, including 0. So your m values would, for L equals 3 would be negative 3, negative 2, negative 1, 0, 1, 2, 3. So there would be 7 values. The answer was D. Protons and electrons are equal if there is no charge. The only case where that happens is A. Here you've got one more proton than electron. You've lost an electron. Here you've gained an electron, and here you've gained an electron. I'm going to go for a couple more minutes and try and do just 3 videos total. So number 21, the set of quantum numbers 4, 2, 2. N equals 4 would be the 4th energy level. L equals 2 would be D. So the best answer looks like this letter D. It describes a 4D orbital. The M quantum number for an electron in the 3p sublevel. If it's 3p, L equals 1. So it looks like 1 equals 1. L equals 1. The best I can do. So if L equals 1, M equals negative 1, 0, or 1. So there are 3 orbitals in the L equals 1. So now let's take a look. Can the M quantum number be positive 1/2 or negative 1/2? No, that's S values. We don't know if it's 0 or not. It could be 0, but we don't know that for sure. It could also be 1 or 1. So the best answer is C. It can be any integer from negative 1 to positive 1. 23, the M quantum number for the 5f orbital. Okay, if it's a 5f orbital, L equals 3. So M equals negative 3, negative 2, negative 1, 0, 1, 2, 3. That'd be 7 values. So now let's go back here. So M can't be positive or negative 1/2. It can't be from 0 to 5 based on what we did up here. Those are actually potential L values. But it could be any value from negative 3 to positive 3. So the best answer would be C. I didn't say that correctly on the test. It should be any value from negative 3 to positive 3. Like that. Number 24, the neon atom, for how many electrons is L equals 0? L equals 0 is equal to an S sublevel. So if you write the configuration for neon, it is 1s2, 2s2, 2p6. So the number of electrons for L equals 0, which is an S sublevel, would be 2, 4, and the answer is C. 25, consider phosphorus. For how many electrons does that have? N equals 3 and L equals 0. Phosphorus, N equals 3, L equals 0, that'd be the 3s sublevel. Configuration for phosphorus is 1, 1s2, 2s2, 2p6, 3s2, 3p3. 15 electrons. So it looks like for N equals 3 and L equals 0, that's 3s. So we're right here. So the answer would be 2, A. And I'm up to almost a 10-minute video, so I'm going to stop there. And then I'll make a third one.